All right, let's take a look. Some of this is old, right? So if you look at this paper, we're using graphing using intercepts. That we already did. And vertex and axis of symmetry. That's new, okay? So the finding the x-intercepts and the finding the y-intercepts, everything on these two columns, this is all what we've been doing, so that's not new to you. But these final two columns, the axis of symmetry and the vertex, that's what's new, and it's going to allow us to make our graph more accurate. So let's take a look. Let's start by looking at this example that's already written. Find the x-intercepts. We know what to do. We plug in 0 for y. We solve for x. How do we solve for x in this case? We factor. We know that if a number times a number equals 0, then either this equals 0 or that equals 0, we solve. Done. Okay? So my two x-intercepts, I can even go ahead and graph these right now if I want. To find the y-intercept, I plug in 0 for x. In this case, right, 0 squared is 0, 5 times 0 is 0, minus 14. That just equals negative 14. So x is 0, y is negative 14. That's old information. Let's take a look at what's new. The axis of symmetry. It has a formula. The axis of symmetry is a line. It's usually a vertical line. Well, for all of Algebra 1, it's a vertical line. We don't turn parabolas on their side till Algebra 2. So it's a line down the middle of the parabola. And a line that's vertical like this has an equation that's x equals a number. Okay? So what we do is we find the equation of this axis of symmetry by using this formula, x equals negative b over 2a. Okay, so the formula is here. Look, I'm going to write the formula, negative b over 2a. Now, what is this b and a? It's here. Here's the equation. This is the standard form of a quadratic equation. It's a times x squared plus b times x plus c. Now, in this case, there's nothing in front of x squared. There's an invisible 1. So a is 1. B is the number being multiplied by x. It's 5 in this case. And c is the constant with no variable. It's negative 14 in this case. So I only need a and b for the axis of symmetry. C is really important later. And you'll notice c is actually also the y-intercept, right, which we observed earlier. So I have my a is 1 and my b is 5. So let's take a look what that looks like. So b is 5. But this is opposite of b. It's negative b. So it becomes negative 5. On the bottom, it says 2 times a. So I do 2 times 1, which is 2. This becomes negative 5 divided by 2. That's negative 2.5. Here's what that tells me. That tells me on the graph, at negative 2.5 is the axis of symmetry. Let's look why this makes sense. My one x-intercept was here at negative 7, 0. My other x-intercept was here at 2, 0. Negative 2.5 is halfway in between, and you can visually see, right? If you actually went ahead and graphed the x-intercepts already, you should be able to visually see when you graph the axis of symmetry that's right down the middle. Now, where's the vertex of a parabola? It's always, always, always on the axis of symmetry, right? The vertex is always this point right here at the bottom of the parabola, where the parabola changes direction, and that's always going to be on the axis of symmetry. So now, what do I know? I know the axis of symmetry is at negative 2.5. I also know that the x-coordinate of this point right here, of the vertex, is negative 2.5. And I'm just looking now for the y value, right? I'm looking for the y value of that point. Well, how do I find it? We know what to do. If we have an x value, we can just plug it into the equation, right? The equation was x squared plus 5x minus 14. So I plugged my x value, negative 2.5, in for x, and then I did the math. Just use a calculator. Negative 2.5 times negative 2.5, positive 6.25. 5 times negative 2.5, bring down the negative 14, stick this whole junk in your calculator, and it gives me this answer. I check that this makes sense, right? Look, this was 0, negative 14. So I'm just visually looking at it. Yeah, this makes sense that this is negative 20 and change. Okay? That looks okay to me. The last thing you're going to do before you finish your graph is you're going to see this axis of symmetry, and you're going to see this y-intercept, and you're going to say, okay, let me just kind of eyeball this. I'm going to reflect it. It's about this far from the axis of symmetry, so I'm going to go that far the other way and make a final point, and that way you'll have 1, 2, 3, 4, 5 points to draw your nice, neat curve through. All right, let's do one complete problem together. Here it is. Okay, so I have x squared minus 14x plus 40 equals 0. This is x minus 10 and x minus 4. How did I know? I saw right away I have two numbers that need to multiply to a positive and add to a negative. I knew right away it was going to be negative and negative. So then I needed two numbers that multiplied to 40 and added to 14. Okay, so this is not new. I'm going to go really fast through this part that you've done a few times. I'm adding 10 to both sides. I get x equals 10. So my one intercept is 10, 0. And I'm adding 4 to both sides, and I get x equals 4. My other intercept is 4, 0. Okay, now my y-intercept, I'm plugging in 0 for x. And that, that looks like this. That's x is 0 and y is 40. Okay, so right away I'm going to start kind of just thinking about what this graph is going to look like. Okay, and the graph is going to look something like this. I'm going to put 40, 0, 40 pretty high up here. And then 10, 0, and 4, 0. Let's call this 4, 0 and this 10, 0. So as I'm thinking about the axis of symmetry, I already know it's going to be right here. Look, I'm going to draw it even before I technically know where it is, because I know it's going to be right down the middle of the x-intercepts. So if this is 4 and this is 10, I can actually just figure out in my head, like, oh, let's see, the distance between 4 and 10 is 6, so it's going to be 3 and 3. I know it's going to be 7 already. I already know, because that's halfway between 4 and 10. Okay, but look, let's do the math. Sometimes it's a decimal and it's not so easy to figure out just by looking at it. Okay, but look, here's my negative b over 2a. Let's go back to the equation. Okay, my a value, my a value is 1, is that invisible 1? My b value is negative 14, and my c value is 40. So my a is 1, and my b is negative 14. So let's go here. My negative b is negative 14. Okay, you can put parentheses on it to make it clear if you want. And then my a is 1. So this becomes negative 14 is positive 14 over 2. 14 divided by 2 is 7, which totally makes sense. And I can see that this line, right, here's 4, here's 10. This line is the line x equals 7. Okay, every point on this line has an x value of 7. Now, I know the vertex is going to be somewhere on here. You know, I'm trying to think maybe, it's probably something like right here, right? I'm kind of picturing what it's going to look like. And here is how I'm going to find the exact value. I'm going to take my equation. It's y equals x squared minus 14x plus 40. And what am I going to plug in? I'm going to plug in this 7, because I already know the x value of the vertex is 7, because that's the axis of symmetry. So when I do the math here, I get 7 times 7, which is 49. 14 times 7, which is 98, and then I'm going to add 40. Okay. So 49 minus 98 is negative 49, plus 40 is negative 9. Okay, let's see if this makes sense. Negative 9, let's see, this was 10, 0, so negative 9 is like, maybe right here. And this looks great, right? Look, I have my x-intercepts. Look, I'm labeling them 1 and 2. Okay, look what it says. I'm labeling my y-intercept, number 3. I'm labeling my vertex, number 4. Okay, and now what I'm going to do, I drew my dotted line of symmetry. My last thing I'm going to do before I draw my curve is I'm going to take this y-intercept and I'm just going to reflect it across this. Look, I'm like just kind of pretending there's like a mirror on this line, and I'm going to reflect it here, put a 5 on it so I can kind of see where my line's going to go. And it's going to look something like this. All right, there it is. Your turn.